Hi there, my name is Niels Berglund. I'm a software architect at Derivco in sunny Durban, South Africa. I'm also a data platform, Microsoft Data Platform MVP. And we're here today to talk about SQL Server and Kafka and how you can set your data free. Before that, let's just tell you how stoked I am that I'm back at SQLBits. Last time I spoke here, that was 12 years ago in year 2008, where I spoke at the third ever SQLBits conference. Now then, so, so the title of the talk, as I said before, is Free Your SQL Server Data with Kafka. However, the operative word here is neither SQL Server nor Kafka, that is data, because data has become more and more important for us. And we think about the data landscape right now. We are generating more and more data. And there has been some investigations made and said that around 2016 we had 16.1 zettabytes worth of data. Zettabyte. That sounds a lot. It is because it is a lot. So 1 zettabyte is 1 billion terabytes. That's a huge amount. However, we are estimating that in year 2025, there will be 163 zettabytes worth of data, i.e. in 9 years time we have tenfolded the amount of data. And the thing is, so this is important. I mean, we as SQL developers, we as SQL Server developers, I mean, we are now taking this data and we are persisting it, we are inserting it, we're updating it, we're deleting it. And if we're looking here, we're having data coming in here from the left-hand side. Data comes in, and we're seeing that here we're in a very low latency environment, right? Well, I should have really highlighted that one. But then, as soon as we come into the database, we're high latency, where we're having transactions and locks, etc. Then, what do we do, right? What do we do with the data? Well, we are querying the data, and we're coming down to the high latency transactions, locks, etc., and we are returning results. So that's how I mean, I don't need to tell you how we are working with data in SQL Server, but that's what we do. And if we're having a look here at Derivco, I have some examples here. If I can find where I have it, there we go. So we have so we have here a database. Uh, Here, gameplay database. We call it gameplay database because we're playing games, right? So let's just ensure that we're in the right database. And yes, absolutely, we are in the gameplay database. Cool. In here, we now have a table that we call TB gameplay. And at the moment, oops, I actually had some data there. So let's truncate out the data from that table. And let's choose again. And yes, we can see now that the table is empty. And the idea here is that when we are playing games, when we are making wagers, we are inserting into TB gameplay, i.e. that's that arrow that comes down from the left-hand side. And we have a couple of procedures that are doing that for us. So we have a procedure here called DBO PR log wager. We take some parameters, user ID, game ID, wager amount, payout amount, and an event time. I mean, this is very, very simple. And then we are inserting it into this table here. So that's cool. So that is essentially the store procedure that is being called when we are in here. In here, right? So that comes down into the store procedure here. Cool. Let's go back to the code. So let's now emulate. So I have here a procedure where we can emulate gameplay because I don't have this service that we are doing this with. I just created a store procedure that takes basically how many rounds of gameplays do we want to play. We're having some min delay, max delay, milliseconds to say how long should we wait between each gameplay. Then some excuse me, some parameters here that decides where we are randomly assigns values for how much we wagered, how much we paid out, etc., etc. Right? So let's go down here and just make sure that this works, right? So set no count on, execute PR emulate gameplay, loops equals 3, we run that. This command's completed successfully, that's awesome. The demo guys were with us. And let's select from the table again. And now, yes, we do have data here in this table, and we can see that we had one of the wagers, one of the plays here, we got a payout amount of 203.40, and this is essentially in cents. So whatever currency this was, if it had been euros, it would have been 203 euros 40 cents, or pounds and pence, and or what have you. Yeah, so that's what we are doing. And so let's go back to here. So that's what we're doing. However, right, so here is the important bit, that back in the day, it was enough to be able to read data from the database, to write data into the database, and then read data from the database. And at one stage or another, we got results back and we made decisions on those results. That is no longer good enough, because we want in real world, we want to react to the data immediately. Right? So we would like to have something that looks like this, that the data comes in once again from the left here, and we are writing it to the database, but at the same time we are still sitting in the low latency part here. At the same time, we want to push this to a service. So this particular event now goes to a service, and here we have consumers consuming from the service this data, and is doing stuff with the data. And it may actually write some data back to the database as well. So that's what we want to happen. But sometimes we can't do that. We don't have access. We can't deal with the services here on the left hand side that generates the data. So we can't get them to publish in here. Yeah. What do we do? So what we then try to do is that, okay, let's write the data into the database as before. We are calling this stored procedure that we have here, log wager. But in that procedure, we are intercepting the data and we push it straight out to the service again. And we have the consumers consuming from the service and potentially writing data back. So now we have the best of both worlds. We are writing data to the database, we are editing data, we are updating data, whatever we do with the data. But at the same time, we are also pushing it up out from the database at the same time as it comes down into the database. So we're getting an almost real-time behavior, a real-time streaming of the data into the service. Right. But so the service then, isn't that complicated? Yeah, it could be complicated because we need to create something where our consumers can connect to, and we need to make sure that the data coming into the service goes to the right place, etc., etc., etc. Right? So yes, it could be complicated. However, that's now where Kafka comes in. So Kafka is built for this. Kafka allows us to do this. Kafka handles a lot, well, I was almost saying all, but a lot, at least a lot of the complexity of this. So as long as we can get data into Kafka, I mean, it's kind of built in that we have the consumers here that connecting in and getting the data from Kafka without us having to do anything in particular, right? So Kafka, what is Kafka then? Well, Kafka is basically the de facto standard for event processing, for stream processing. It started back in the day at LinkedIn. I think it was around, well, 2009, 2010, around there, where people wanted to enhance LinkedIn's messaging systems. It was open sourced LinkedIn saw that, hey, this was kind of cool. We can do cool stuff with this. So let's open source it and let's give it out to the public. Then at the same time or a little bit later, the boys and girls that developed Kafka at LinkedIn, they founded this company called Confluent, which is now the commercial arm of Kafka. Kafka is open source, but it also has a commercial part where we can buy enterprise licenses, etc., from Confluent. And Confluent drives a lot of the Kafka development and Kafka inventions, etc. It's a distributed streaming platform. We are not publishing messages per se, but we are publishing streams of events. And these events, they are being persisted by default onto disk. And then we can process these streams. And where we are persisting them to, we are persisting them to the equivalent of a commit log. And us in the database world, I mean, we love logs because that's what SQL Server is based upon. We have our transaction log, and Kafka has the same. We have a log where we are seeing exactly what is happening. And why we like logs is because they are trustworthy. And the Kafka logs, they are distributed over multiple machines if you so want. And that is for scalability as well as for resilience. So some key concepts. So we have a cluster. We talk about the Kafka cluster, and that cluster is essentially one or more brokers, i.e. the box on which Kafka runs on. So even if you're running Kafka on only one box, it is still a cluster. It's a cluster of one. And Kafka had a notion of topics, and that's where we are sending the messages to and consuming the messages from. But where the data ends up, yes, it ends up in a topic, but like a database table, a topic can be partitioned. So we can ensure, and once again here now, this is for scalability, we can create multiple partitions on a topic, and the data is then distributed out across those partitions. Right? So let's have a look here at my sorry. Let's start up a browser. And let's connect to my Kafka cluster. So when we are installing Confluent Kafka, we are getting a web front end for it called the control center. And here we can now see on the left-hand side how I have one cluster, CO1, cluster 1. And if I click on that, we can see here that I get an overview. We can see how many that I have one brokers. There are 58 topics. Well, I haven't created 58 topics. I actually have created 2, but we have the 58 topics. There's a lot of internal topics. And so if we click here on topics, we can see that here are someone that are public, and these 2 are the one that I have created, test topic and wagers. Cool. So that's kind of the basis of Kafka. Right. Kafka Connect. So for what we are talking about today, Kafka Connect is important because that allows us to connect Kafka to other systems, to external systems like databases, key value stores, etc. And we are using in Kafka Connect, we are using connectors to connect to external systems. And a source connector is the connector that gets data from the external system, i.e. from the database, and pushes it into a topic. And a sync connector ingests data from topics to external systems. KSQL DB, the last thing here we're going to talk about in the Kafka 101 is an event streaming DB. And it allows us to, in a very, very easy way, build stream processing applications. So remember how I said a couple of slides back that Kafka is really where we are sending streams. We're having streams of events, and now we can build applications against those streams, those events. And yes, we could do it before KSQL DB came out, but then we had to write Java code. We had to use something called KStreams, etc., etc. And so now in KSQL DB, we are writing normal ANSI-like SQL. And I mean, we love SQL. We are SQL developers. We like SQL. So I can very, very easily write a query against my streaming data that I can use for fraud purposes or whatever I want to do that. So KSQL DB is really lowering the bar for implementing streaming. So let's come back to here. SQL to Kafka. So now we know that we really want to send data from SQL into Kafka. So the data comes in here and then meow, we want to go up like that, right? So what options do we have then? Right, let's have a think about that. So we have SQL Server Service Broker, SSB. Service Broker was introduced with SQL Server 2005, and it's basically a queuing system in SQL Server where we are pushing data into queues, and then we are consuming from those queues. In SQL Server 2008, I think it was 2008 R2, I may be wrong, Microsoft introduced what they call an external activator, where we could have an executable outside of SQL that listened to queues inside SQL and then did stuff with that data. So we could potentially see here that we're using the external activator to read data off a queue and then push from the external activator, push that data into Kafka. However, at Derivco, we're still using, we used Service Broker quite a lot, but yeah, it's a little bit of a black box. Well, if something goes wrong, you don't really know what is going wrong. And we also found that we had issues with performance because at the end of the day, these service broker queues are really tables under the covers. And we got into locking, blocking, deadlocks, latches, all that bad stuff. So that's why I have this sad face against service broker. But it is an option. SQL CLR, well, .NET inside SQL Server, we'll talk more about that. Also introduced, by the way, in SQL 2005. CDC Debezium, change data capture with a tool with a framework on top called Debezium, which listens to changes to tables and is doing stuff with that. And finally, SQL Server external languages. So external languages was introduced SQL 2016 with where you now can write, where you in SQL 2016 can write R code, and you can from inside SQL Server call that R code outside of SQL Server. So it's an external runtime. And 2017 introduced Python, and 2019 introduced Java. So we can see here that by using external languages, we could use a Kafka Java client to send data to Kafka. Right. So SQL CLR. So as I said, that is .NET CLR hosted inside SQL Server, hosted in the same memory process, well, hosted in the same memory space in the same process as SQL Server. And what we do, we write classes, methods in a .NET language. These methods, these classes can reference DLLs written also in .NET. We are compiling now what we have written here to a DLL, which we call an assembly. And then we register the assembly with SQL Server, and we are creating T-SQL objects that invokes methods in this assembly. And the users are not calling the .NET code directly, but they are interacting with the T-SQL objects that we have created. So something like that, this. So on the up in the right-hand corner here, we have a SQL Server user. He calls a T-SQL method, a store procedure or a function, and that T-SQL store procedure function calls into the .NET code that is now sits here in the SQL Server process. The .NET code have access to tables in the database as before, so it can write data, it can retrieve data, and also the .NET code can access, can access external resources. So the .NET code can potentially call Kafka if we so want. Right. So SQL CLR and Kafka then. There is a .NET version of the Kafka client. So Confluent has a .NET version of a Kafka client. So Kafka is written in Java, and they have a very full-fledged Java client. The .NET client is now up to par with the Java client. So what we would want to do is we are creating a SQL CLR assembly that references the Kafka client. We then write methods which uses the publish methods in the Kafka client, and we are creating a T-SQL procedure against now these methods that we have written. Cool. Doesn't sound bad. That doesn't sound too bad. And as we used to say at Derivco, how hard can it be? What could possibly go wrong? And if I say that, well, then we know there's a fly in the ointment. So the Kafka.NET client are using assemblies that are not allowed in SQL CLR. That's not good. So if we try to take the .NET client, the Kafka.NET client as it was, and deploy it to SQL Server, we would get a big fat ugly error saying that you cannot do this. The other thing here is that under the covers, apart from these .NET DLLs that the Kafka client is using, is they are also using a C wrapper called librd Kafka DLL, which also is needed by the .NET client. So, and we can definitely not put this librd Kafka DLL in the in the database. And therefore we cannot create it as an assembly. So we need to load it manually. I'll just show you something here. So what we can do, which I think I had here on my slide, was that we can. So the .NET client is open source. The Kafka.NET client is open source. So we can take the .NET client and basically compile it ourselves, because it so turns out that the part of the Kafka.NET client that are using these DLLs that we cannot create in SQL Server are the consume parts, and we don't want to consume, we just want to publish. So what we are doing is we're taking the code that has to do with publishing and puts it into a project, and we can compile that project. And that's what I have done here. Right? So I have taken the open source, the source code for the Kafka.NET client, chosen whatever I need to use, and compiled that into a DLL. Right. And then I have in my DLL, in my class here, class 1 that we see here, right? That's essentially my code. In here, I am referencing, as we see here, my Confluent Kafka. I am creating an method which will be the will be the method that will be exposed, which I will create a procedure over. And in that method, I'll take whatever parameters I need, and then I'm calling into my second method here, which is doing the hard work and pushes data to Kafka. And here we can see how I'm now loading this librd Kafka DLL from a well-known path that I send into this send into this method. Yeah, good. Um, so that's that. We have seen that. Right. So now when I have done that, I can now go ahead and do some stuff here. So I am now in my database. Let's see that I am in my database. Yes, I am in gameplay DB. Cool. Um, what I want to do is, if I already have some objects, let's run this. Yeah, that's fine. Let's drop the assembly if I had it. And now what I'm doing, I'm creating this assembly. I am deploying my DLL to SQL Server. And I do that through the create assembly function, the create assembly call, where I'm saying from. So I'm creating this assembly, which this is just a name. You can call it whatever you want. I'm saying create assembly Kafka producer from a file path. In this case, I'm using a file path because the cool thing is, if I'm using a file path, all the dependent assemblies that are required will automatically be picked up by create assembly. And I'm saying that I'm doing it here with a permission set of unsafe, because this is definitely not safe code. We can do a lot of bad things here, but I trust myself. That's the famous last words, eh? So we're doing that. Cool, commands completed successfully. That's awesome. If I'm selecting star from sysassemblies, we can now see that I have here. Okay, cool. I have my Kafka producer, that's my code. And then here I have that Kafka SQL CLR. So that's now the customized Confluent Kafka client. We are then creating my object, my procedure over that method that I wrote. So creator alter, PR publish to Kafka CLR, sending in where are my servers, which topic, where is the path for Kafka, librd Kafka DLL, a partition key, and the message. And that should hit this, right? The Kafka producer, the assembly, the fully qualified class name, which is namespace plus class, and then finally the method. Yeah, so let's do that. And so far, the demo gods are with me. Commands executed successfully. Let's test it now. So publish to Kafka CLR. I'm saying, where is my Kafka broker or Kafka brokers? In this case, I only have one, localhost, port 1992. What topic do I publish to? So now when we have deployed this and we see that the connector is up and running, let's go back to Confluent Control Center and have a look at if we can see that if something has changed there. And yeah, look at this, eh? So now we have some new topics here. So these topics, they're all topics for metadata around CDC. We do not have anything here yet for the actual table that we want to do CDC on. So this is pure metadata stuff for existing tables and for the DB, etc., etc. So now it's time then to see what we can do with the table. So we're back in Azure Data Studio. And what we now want to do is that for SQL CLR, we we did change this DBOP or log wager to have SQL CLR calls into it. And that's what we want to take out now, because now the data will come from this table directly through CDC. So let's run this proc, create it, alter it. Life is good. We still don't have anything in my gameplay, and let's now emulate gameplay here. So let's run my proc, 3 loops. That's fine. Let's see what happens here. And we now have some data in my table. There we go. Awesome. Then it's time to see, do we have something new here now in among my topics? And when we look at the topics, yes, we do have a new topic here, DBOTB gameplay. Cool. So that's now from the table that we are using CDC on. So drill into that one, look at messages, go from offset 0 from the very beginning, and now we have here 3 rows in the table. So here we have now used CDC and Debezium together to get data from the actual table. Before we doing the final bits and pieces here, let's tear this down. So we're disabling CDC on the table, we're disabling CDC on the database, and we are now truncating out the table. So nothing there, right? So let's go back to slides for a while. So we have seen CDC, we have seen Debezium, we can see how we can get data straight from tables into Kafka. The final thing that we're going to talk about here is the Extensibility Framework. And that is something that allows us to call external languages such as R and Python, and also Java, which was introduced in SQL Server 2019. So once again, R, Python, and Java, the runtime sits outside of SQL Server, so we can call from inside SQL Server out to these runtimes. Hang on a second here. So Java and Microsoft. I don't know. I mean, I'm old enough to remember when Microsoft and Sun were in open warfare, against each other due to the Java language. Oh, how times have changed today. So now Java is a first-class language within Microsoft. Anyway, so external languages. So it means that, as I said, they're external to SQL Server. They do not run in the same memory space or process. So it's quite opposite to SQL CLR, but similar to extended store procedures. In order to use a language, it needs to be registered in the database, and then we are executing into the language using sp execute external script, a new procedure in SQL Server. The way it looks like is that when we are saying that we want to use R, Python, or Java, we are getting a new service part of the SQL installation, and that's something called the Launchpad process, the Launchpad.exe. And when we are executing this execute external script, as you can see down here at the bottom, we are defining what language we want to use. And based upon that, this Launchpad service routes the script, routes what we are executing to something that will spin up either our Python or this external runtime, in this case Java. So we need to write this Java code in a specific way. We are inheriting a class from an MS developed SDK, and in the class we have an execute method which will execute what you want to get done. And then we have helper classes for parameters and data sets. So here's just an example where we are extending this class from the SDK. We are setting some parameters. Then we are getting into the execute method, and we are doing stuff. We are executing it like what we see here. Execute external script saying saying it's Java. Uh, this script is now defining the Java package and the class Java test1, and that will then cause Launchpad and other services to call into the execute method in this Java test1. Right. So I have here deployed already Java as a language. So when we're looking at external languages, we can see that we have, uh, Java here as an external language. And the code we are deploying, the code we are using they are being deployed as external libraries. And if I do look at that in here now, I have that SDK that I mentioned. And also an Java test language, the one that we saw on the slides. And if I now execute here, we will see that we will get back something from my Java class. So this works, cool. Now, what we want to do is we want to create something similar to what we did with SQL CLR. We want to create some classes where we can call into Java, where we can call into the Java client for Kafka. All right. So let's go over to Visual Studio. Visual Studio Code, where I have my code. Which I call SQL Kafka Java. We can see here how I'm extending this abstract SQL extension executor, as we saw on the slide. I'm setting some parameters. Here is the execute method, where I'm getting in some data, which I'm parsing out to get the interesting parts, the broker, partition, topic, and also my actual message. Right? Then I'm calling publish to Kafka, setting up some properties, setting up what are the serializers, and eventually calling send. And this is now using the Kafka client, the Java Kafka client, which comes as part of Java. All right. So let's go into Azure Data Studio. So what we are doing is we are checking that we're in the right database. We are looking at my external libraries, which we have the ones that we saw before. Then we are now creating my external library. So this is now my compiled code where we can call into the Kafka client. Calling that. Now when we're looking, we can see that we have my Java published to Kafka. That's cool. If I wanted to, I could test it, but we are running out of time. So we will create a procedure where in this procedure is now execute external script. This is now the package and the class. We are selecting in some configuration data, and then that's it. So let's hook this in here. Cool. And let's change my generate and publish wager event to, instead of calling into SQL CLR, we're calling into publish to Kafka from Java. We're running that. We are hooking in my generate and publish wager event into my log wager, which we took out for CDC. Truncating out my TB gameplay table. We are calling now execute emulate gameplay with 3 loops. This will take a little while. We will probably see some warning messages here because there are certain Java stuff that we are missing. I at least hope that this will work. And yes, cool. So we're getting some warnings here about standard out to console. There are some classes that we can't load, but this is only warnings. If we're looking at gameplay, I now have my three rows in gameplay. And then let's go to Control Center and look in wagers, messages from offset 0. And here we have 3 new wagers in that in that topic. So here we have now seen how we, through using external languages, Java, as a matter of fact, are publishing to Kafka from a hook point in a stored procedure. So we have seen that how we are deploying, how we're creating an external language, how we're creating that Java SDK that is required, and then finally how I'm creating the actual library that calls to Kafka and hooking it into my various procedures, and that's that. So here what we have seen now is that we want to get data out of the database in near real time. And we want to push it to Kafka because that is the de facto standard for event streaming. And we have seen 3 different options to get data out. We can use SQL CLR, we can use CDC Debezium, or we can use the Extensibility Framework and external languages. The one thing that I just want to mention to you here before we finish this off, that CDC Debezium, since it's not reading from the log, but it's reading from CDC tables that is being created when we are enabling CDC, CDC Debezium, you can get a slightly higher latency and a slightly higher performance impact. So just be aware of that. And that's that from me. Thank you so very much, guys and girls. If you have any questions, and if you want to ping me around this, here are my my address, nielsitberglund@gmail.com and https nielsberglund.com. Thank you again.